So before we talk about fractions, we need to talk about just two words: factors and multiples. Now, when I was in school, I think I was sick or absent on the day that we did factors and multiples. So I come up all the way through school having, not really understanding this simple thing, factors and multiples, right? But let me just say we have the number 10, for example, right? You can see that the multiples are those numbers that are bigger than 10. So 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, and so on. So the numbers that are bigger than 10, those are your multiples. The numbers that are smaller than 10, those numbers that could go into 10, those are your factors of 10. So 10 divided by 2 is 5, 10 divided by 5 is 2, 10 divided by 10 is 1. So these are the factors of 10. All right. So factors, when you refer to factors, now factors, this is why multiplication glues numbers together. Multiply equals glue. Because if you think of a number like, say, the number 6, this is really just two factors multiplied by each other. This is really 3 multiplied by 2, and we can write it as one number 6. Yeah. So these 6 is basically 3 times 2, 3 and 2 glued together. Yeah. So these are factors and multiples. We have started fractions. We're gonna finish it today. So we're talking about fractions. A fraction may describe part of a whole. For example, right? You could see I have this fraction here, 2 over 3. This is the fraction, right? The top number is the numerator, also known as the dividend. The dividend is the number that is being divided, right? The line is called the vinculum, and the underneath is the denominator or the divisor, right? You could think about it like the Terminator. The Terminator does do the terminating, right? So your divisor does do the dividing. You can see this fraction describes the top number is the number of parts out of, the bottom number is the whole, which is the total number of equal parts in the whole, right? It all sounds very complicated. It's not. This is the whole. You can see the whole is made of 3 parts. Out of the 3 parts, I have 2 shaded. 2 out of 3, right? You could also think of fractions in terms of divide. So 10 divided by 2 could be seen as 10 over 2, which is an improper fraction. Yeah. So basically, fractions could mean part of a whole. They could mean divide, as in this case, right? Or in all cases, right? And again, you can see that this is the number that is doing the dividing. Yeah. So this is the divisor, like the Terminator. Right? And this is the terminatee or the terminatend. The terminatend or the dividend. The number that is being divided. Let me hear my dunnits and any questions. These are the different types of fractions that we're gonna be dealing with, right? The first type of fraction that we're dealing with is the proper fraction, and the proper fraction is like, an example is like 2 over 3, where the numerator is smaller, the top number is smaller than the denominator, right? So that is a proper fraction. And then we have the improper fraction like 3 over 2, and that is where, that is where the numerator is larger than the denominator. Larger. It's larger than the denominator. The numerator is larger than the denominator, right? Then we have the mixed number. The mixed number is when you have a whole and a proper fraction. right? So this is a whole. All right, so this is one pizza, and then you have a half of a pizza left. So this is a proper fraction. And that gives you a mixed number. These are the three that we're gonna be doing today. And we're gonna be talking about everything to do with these three today. These three we will tackle in subsequent classes. But of course, this decimal here, like a half, for example, will be written as 0.5 in terms of the decimal system. Right? A half could also be written as 50% in terms of the percentages. And of course, a half could be also seen as being in a 1-to-2 ratio. So we're talking about an improper fraction and a mixed number. And how do you convert an improper fraction to a mixed number? And how do you convert a mixed number to an improper fraction? So you can see I have these arrows here to show that it goes both ways. A mixed number here is an improper fraction. An improper fraction is a mixed number. And how do we convert from one to the other, right? So to go from say improper to mixed, so we're going in this direction here. So what we have to do is we actually have to divide. You have to say, well, how many times can 2 go into 3? How many 2's are there in 3? Well, 2 into 2, 1. There is 1 2 in 3, and then I'll have our 1 remaining. So 2 could go into 3 one time, and then you have our 1 remaining over that same denominator. And so you get the mixed number, right? Again, over here we have example 2. How many times can 3 go into 7? Well, 3 could go into 7 2 times. 3 2's are 6. And then you have 1 remaining to give you 7. That will be over your 3, right? How many times can 5 go into 21? Well, 4 times it could go into 20. 5 4's are 20. And I'll have a 1 remaining. Right? And you have your mixed number. How do we convert back from a mixed number to an improper fraction? Well, it's just a procedural thing. You take the denominator and you multiply it by a whole number. So 2 multiplied by 1 will give you 2. That is an equal sign there, but I'm trying to go in a circle, right? And you know what? Let me just write it like this. That is equal to 2. So 2 multiplied by 1 is equal to 2. And then you add it to that one, right? So 2 times 1 is 2. Plus 1 will give you 3 on the original denominator. So again, you multiply the denominator by the whole number. 2 times 3 equals 6. And then you add it to the numerator to give you 7 on the denominator, 3. Again here, 5 times 4 is 20. And 20 plus 1 will give me 21 over 5. So we know how to go mixed numbers to improper fractions and so on. Let's talk about equivalent fractions. Where is my pen? Look at here, right? When we multiply the numerator and denominator by the same whole number, we get an equivalent fraction. Equivalent fraction, right? For example, if I have a half, right, and I take this numerator and I multiply it by 2, it is not a fraction, right? I'm multiplying the numerator by 2 and I'm multiplying the denominator by 2. Right? Well, what am I actually doing? Because if you put the 2 over the 2, that is 1, right? Because 2 into 2 is 1. So you multiplying the fraction by 1. So you're not actually changing anything. Anything multiplied by 1 is itself, right? So you just have to make sure to find an equivalent fraction that you're multiplying the top number and the underneath number by the same whole number, right? So 1 times 2 is 2, and then at the bottom 2 times 2 is 4. So we can see here that 2 over 4 is, and we just use 3 for equivalent here. In fact, look, I have it written here. Therefore, 2 over 4 is equivalent to 1 over 2. Right? So they are equivalent fractions. And I didn't have to multiply it by 2. I could have multiplied this by 3 or by 5 or by 10 to find the equivalent fraction. So look, and the other example is I take the half and I multiply it by 3 instead. So 1 times 3 is 3, and 2 times 3 is 6. So 3 over 6 is equivalent to a half. Right? They are both the same fraction. Right? When we multiply by 2 over 2, we are essentially multiplying by 1. And so the fraction is equivalent, because you're not really changing the fraction. And look, I have a little diagram here. This is what 1 over 2 does look like. And this is what 2 over 4 does look like. And as you can see, they're pretty much the same thing. In fact, they are the same thing. So they are equivalent. Let me hear my done it. Right, so we know about equivalent fractions now. We're getting into it, the adding and subtracting of fractions. But this time we're talking about the same denominator. Let me take off the capybara because things are getting serious now. Right? We're talking about the same denominator. When fractions have the same denominator, we simply add or subtract the numerators. That is it. So you can see here that I have the same numerator, 7 and 7. So all I have to do is add the same denominators. All I have to do is add the numerators. So 3 plus 2 over the same denominator. Yeah, over the same, so the denominator does not change. You just add the numerators. 3 and 2 is 5 over 7. Right? Please make a note of this. Please get familiar with this. You're going to see this again, especially in algebra. Right? So when you see, and we'll talk about it just now. Example 2, same thing with subtraction. You just subtract your numerators. Right? So this is over the same denominator, 9, and it'll be 5 minus 4, which is 1 over 9. Now similarly, we could see that, remember this thing I had the brackets around? 3 plus 2 over 7. If you see this, then this means that both the 3 and the 2 share the same denominator, 7. So if you see 3 plus 2 over 7, right? That is saying that you have two fractions over the same denominator. The reason why I make this point is because some people, you might see 2 plus 3 over 2. And some people just feel like you could cancel this 2 and this 2 and you're going to just have 3 remaining. No. Remember addition, the separate numbers. So this addition sign is separating numbers. So that means that because of the addition sign, this is 2 fractions over the same denominator. This is 2 over 2 plus 3 over 2, right? And so you can see here we have 1 plus 3 over 2, right? That is what we get there, right? Which we could see to be 5 over 2, right? But you can see you cannot cancel. So another example is when we have algebra, and some people might see x plus y over x, right? And they might want to cancel this x and give me the answer as y. No, this means x over x plus y over x. So you can see in this case, we were talking about adding the two fractions that have the same denominator and putting the numerators over the same denominator. But in this case, we're talking about when you're already given two numerators over the same denominator, this is what it means. Right? That addition sign here is really the addition of two separate fractions, because addition the separate numbers. Yeah, and so we can see a little summary here, and this summary says that if you are adding or subtracting two fractions that have the same denominator, you just add or subtract the numerators over that same denominator. And remember, it is worked the other way around too, that you could take this and split it back up. Yeah, let me hear Dunnits for this. Right, now we are talking about adding and subtracting fractions with different denominators. Now I know all you learn about LCM and HCF and all them kind of thing. I'm just gonna show you one method. This method does work for all fractions. This is the method that you will have to use when you're doing algebra fractions as well. So just learn this one method, right? Adding and subtracting with different denominators. So the one method is this. For adding or subtracting is the same method, right? You multiply your denominators. So that's the first thing you do, is multiply the denominators, right? So when you multiply your denominators, 5 times 3 is 15. Then you cross multiply 2 times 5. Right? And on the side where the 2 is, 5 times 2, 2 times 5, I'm going to put the 10 here on the side of the numerator. Then you have that plus sign that was in the middle. So I'll put the plus sign there. And then you cross multiply here. 4 times 3. 4 3s are 12. Right? And so you can see here that we have 22 over 15. Which could be, let me see if it have 22 over 15. Yeah, right. So it'll be 1, because 115 could go into 22 once, and then you'll have 7 remaining. Right? So 15 plus the 7 will give you the 22 over 15. So this is just the one method, right? I'm gonna do it again for subtraction here. You'll see the method again here, right? You'll see that we have just number 1, multiply your denominators. 7 times 3 is 21. Then you cross multiply. Now for subtraction, this is very important. You cross multiply 4 times 3. So 4 3s are 12, and I put in that on the side of the denominator, the 4. Because it's the 4, the numerator. Why I keep mixing up them words? The numerator here, the 4, the numerator. Yeah, so the 4 times the 3, the numerator, that is on that side, right? Then you have the minus there, and then you have 2 times 7. 7 2s are 14. Right? And so now you can see 12 minus 14 is minus 2 all over 21. Right? And I don't think this could be reduced anyhow. 2 over 21. Nope. That can't be reduced, right? Now, you can see I have this little note here. Look on your calculator. This is your normal scientific calculator. And you can see over here is where we have that button I'm talking about. And that button is for fractions, right? So, for example, just a little bit on how to use that button. right? If it is that you want to type a fraction, let me just say 10 over 2. Let me not say 10 over 2. Let me say 10 over 30, right? You wanted to type that in to get a simplifier. You want the calculator to simplify it for you because you're lazy, right?
1 over 2.
Yeah, but I just using a very simple example. It could be a messy thing like this, and you want to see if it could reduce, or it could be something strange looking like this, and you want to see if it could reduce, and you don't want to bust your brain, right? So what you'll do is you'll put 20, you'll press the button, 10, the numerator, you press the button. I'm not gonna write the button, but that stands for the button, and then you put 30, right? On the screen, you will see 10, you'll see this symbol, and you'll see 30. And that means 10 over 30. And then you just press the equal button, right? And then this will turn into this on the screen. And let me just see. Yeah, that's how it does look. Right, so that's how it does look on the calculator. Right, 1 over 3. You could do mixed numbers on the calculator too. So if you wanted to type, say, if you wanted to type, say, 1 2/3, you would have to do 1 and type the number, press the button, and then 2 and press the button, and then 3 and then press equal, and you would have this on the screen, and that means 1 2/3. So this is how a mixed number would look on your calculator. Let me hear some donuts for this, please. All right, so for this first question here, we just have to multiply your denominators first of all. So 7 times 11 is 77, right? And then you multiply 7 4s are 28, plus 3 times 11 is 33. And so the final answer you should get should be around 61-ish over 77. Now, 10 times 14, that's 140. So this is something that might have to reduce, because that's pretty big, right? 13 times 10 is 130, minus 3 times 14. Where's 3 times 14? 3 times 14 is 42. Right. And so now we have 130 minus 42 is 88 over 140. Now, in terms of the calculator, I'm just going to put this in the calculator, and I'm going to put 88 button 140 equals, and I see that it goes down to 22 all over 35. Now, if you didn't have a calculator, you would have had to figure out that if I divide 88 by 4, right? So 4 into 88 is 22. Yeah, and then 4 into 140 is 35. So you would have had to be able to figure out that is a factor of 4 that you would have had to use to reduce that. So that is what I say. When you are in a situation like multiple choice paper 1, right? Multiple choice paper 1 is where you'll have to use mental math, right? You wouldn't have a calculator, but they wouldn't give you a fraction like this. They'll give you a fraction that you can figure out, right? So that is why, in a paper 2, you could get a fraction like this, but that is because you have your calculator, so use it. So this same method we use for the addition and subtraction of fractions And so here you could see that when adding and subtracting fractions, this is a summary that if I have a fraction a over b plus or minus c over d, what do? You multiply your denominators, right? So you will have b times d is bd. Remember, multiplication glues numbers together. We can write it as one number, bd, right? Then you cross multiply. A times d is ad. So this is kind of like a formula for it now. Plus or minus, whether you're adding or subtracting, and then you have your c times b, which is bc. So this is kind of like a formula for the adding and subtracting of fractions, right? Anybody still writing? Now, this is not the only way to add and subtract with different denominators. When we're talking about adding and subtracting fractions with different denominators, it have a different, easier method, right? And we can add or subtract fractions with different denominators by using equivalent fractions. So for example, I have a fraction here with different denominators. Yes, you could multiply the denominators and cross multiply and you'll get your answer, no problem. But we could also use equivalent fractions, right? You could change one of the fractions or you could change both of them. And so you can see here what I did was I decided to take the 2 over 3 in this case here, and I multiply it by 5, right? So 2 times 5 is 10 and 5 times 3 is 15. So I'm deciding to change the denominator for both of them to 15, right? I have my plus sign in the middle here. Then I have the 4 over 5. So I take the 4 over 5 here and I multiplied it by 3. So 4 3s are 12, 5 3s are 15. So you see now I have 2 fractions over 15. So I could just add my numerators. 10 plus 12 is 22 over 15, 1 and 7 over 15. So this is another way that we could use to add fractions with different denominators. That is changing it to the same denominator. How do we change it to the same denominator? By using equivalent fractions method. Right? The equivalent fractions method. And we could use that to change the denominators. Yes? Let me hear my done it, please, or any questions. If anybody don't get it, let me know. Alright. So we talked about the adding and subtracting, and guess what? When it comes to fractions, right? Adding and subtracting of fractions is the hardest part, So we're pretty much done with the hardest part of it, right? Now it's time to multiply fractions, right? And I have a little spotlight challenge for Olivia. Olivia had to prove something, but just now we're going to see. My older students, people like Isaiah, and well, I know Sarah a little sick. Who's my older students, boy? Ayanta. Where Ayanta? Oh, look, Ayanta there. Brianna. Well, no, Brianna was a thing, but yeah. Anyway, you can see. Anaya is one of my older students. So I have 4 older students here. All right, who should be able to help me out. So to multiply fractions, you simply multiply the numerators and the denominators. That is all. That is it. That is everything. So if you have this fraction here, 2 over 7 multiplied by 3 over 5, just multiply 2 times 3, right? So that is just 2 times 3 over, and then you just multiply your 7 times 5. 7 times 5. And you can see 2 3s are 6, 7 5s are 35. And I'm gonna use the calculator because I ain't feeling to do any brain work right now. No, it cannot be reduced. Same thing here. You just multiply the numerators. 4 3s. 4 times 3 is 12. And you multiply your denominators. 5 times 10 is 50. And I know 12 over 50 can be reduced. But I'm not going to reduce it. 12 over 50 is 6 over 25. And if you want to know how I reduce that, to reduce it for real, well, you'll have to find out what do they have in common. And in this case, all they have in common is 2. That is the only thing I could see that they have in common is 2, right? So what do they have in common? They have 2 in common. So 2 into 12 is 6, and 2 into 50 is 25, right? So this is an equivalent fraction, is what this is. These are equivalent fractions, because if you take this and multiply it by 2, you'll get this. And of course, I just wasn't feeling to do the reduce, so I just used my calculator. That's fine, nothing wrong with that. But just in case you wanted to know how, I'll just give you a little minute for this one. Multiplying and that's it for multiplying fractions, you know. We have a couple of other little notes here. We have a little challenge coming up, but after multiplying fractions is dividing fractions, and then it's your turn, yeah? Multiplying we almost done, you know. We almost done. And this is just a little formula for multiplying fractions. So if you have A over B multiplied by C over D, you just multiply your numerators. So that'll be A times C. And then you multiply your denominators. That will be B times D. And then that'll give you AC over BD. That is all. 30 seconds. Moving on.
TikTok just now, right?
By the way, check out the Semicircle Academy on TikTok. Like it up, share it up, all of that kind of stuff. Please.
Yeah.
Right? That'll be nice, right? Let's do some amazing things down there. Notice how we can cross cancel if they share factors. Right? So this is cross canceling. So you know that when it is I'm multiplying fractions, normally I'll multiply my numerators and then I'll multiply my denominators, right? But if they share factors, like I noticed that this 2 into 2, 1, 2 into 16 is what, 8? Right? So this 2 could cancel with the 16. Right? This 3 into 3, 1, and 3 into 9. Actually, let me do that in a different color. This 3 will cancel 3 into 3, 1, and 3 into 9 is 3. And so what do we end up with? We end up with 1 over 1 multiplied by 3 over 8. Which is just 3 over 8, right? Here is the challenge. Check this challenge. And I'm going to take off Mr. Capybara for this. Check this challenge, right? How is it possible that I could take the numerator from one fraction and cancel it with the denominator of a totally different fraction? It's not like if there's the same fraction and I could just reduce it, you know. It's not the same fraction. One numerator is from one fraction. The denominator is from the other fraction. Huh?
I think it's a numerator and denominator situation. Just to go into 16.
Yeah, but how is it? Why? Prove why. So you telling me, right? You telling me, Omari, that I could cancel this 2 into 2, 1, and I could cancel it with the denominator of the other fraction? That is what you telling me?
Yeah.
Well, guess what, Omari? I don't believe you. Prove it. I don't believe you. You telling me that? You telling me that I could take, but why I can't do that? If it was 2 over 3 plus 9 over 16, why I can't do that with addition? Why it is that I can't just cancel this and this with addition? Why it is I could do it with multiplication? Isaiah just put in the chat, yes? Because of 2 words that I hate to write. I hate to write these 2 words because multiplication, I hate to write that word, boy, is commutative. That is why. So that means, therefore, if you have 2 over 3 multiplied by 9 over 16, you know that you could multiply your numerators, and so that will be 2 times 9 all over. You can multiply your denominators. 3 times 16. But multiplication is commutative. So that means that 2 times 9 is the same as 9 times 2. Yeah, so I could switch that, but I don't have to switch the denominators though, because 16 times 3 is the same as 3 times 16. And so now I could split it back up, and look, now I get 9 over 3 multiplied by 2 over 16. And so you can see here that now I could cancel the 2 with the 16, and I could cancel the 9 with the 3. Right? And so what we're trying to say here, because multiplication is commutative, means that 2 over 3 multiplied by 9 over 16 is the same as saying 9 over 3 multiplied by 2 over 16. So all of this explanation is really just for you to understand why this work. But this here is really what we're talking about, that you can cross cancel things when you're multiplying, right? And this is the reason why. So I'll just leave it up there for a little minute, right? So we talk about multiplying fractions. You just multiply your numerators and your denominators. How do you divide fractions? Well, all you have to do is we flip the divisor and then multiply. Remember, the divisor is the one that is doing the dividing. Yeah. So 2 over 3 is being divided by 1 over 7. So the divisor is the one that comes after the divide sign. Right? And you know, it might have a question where you could see this question in a different way. You could see this question in a paper like this: 2 over 3 divided by 1 over 7. And of course you see that and you want a ball, right? But really all you had to do is flip the divisor. So you're just flipping this one. So you'll have 2 over 3 multiply by 7 over 1. So you see how it flipped. And then you multiply, right? So 7 2s are 14, and nothing could cross multiply, nothing could cross cancel there. And 3 1s are 3. 14 over 3. 4 3s are 12, 13, 14. 2 over 3. Same thing with this. You just flip the divisor. So you can see we will have 4 over 5 multiply, and you flip, it'll be 10 over 2. And you can see in this case, yeah, we could cross cancel. 2 into 2, 1, 2 into 4 is 2. 5 into 5, 1. 5 into 10 is 2. And so 2 multiplied by 2, the answer is 4 over 1, which is just simply 4. We have A over B being divided by C over D, and that is equal to A over B multiplied by D over C. So this gets flipped. Well, now it's your turn. I'm skipping all of these. All of these is just, and we're going on to these. These are the guys that you'll have to do for homework, right? So next class, we will actually spend the next class doing some fractions questions, right? So you can take a screenshot of this, and you can take a screenshot of this. And my new students might get a little bit crazy when they see this. This is the Spotlight Challenge. If you understand fractions and you're really good at fractions, try a hand at this. If you could do this, then nothing in fractions will ever give you problems. If you could do this, right? So we have the Spotlight Challenge. Give it a screenshot. All right. So we are only going to tackle a couple of questions. Let's tackle these two. These two here. And the reason why I'm tackling these two here is because we have mixed numbers, we have addition and subtraction, we have BODMAS as well. So you could see how BODMAS does play a role with these things. BODMAS does play a role. Fractions is one of those things you need practice. Of course, we're dealing with BODMAS, but you can see that in this case here, it have no brackets, it have no multiplications and divisions, it's only addition and subtraction. So this is like the end of BODMAS, right? And when you only have addition and subtraction, it's the associative law, right? So you could actually take this and minus this from this if you wanted to. Yeah, because addition and subtraction separates numbers as long as you keep the sign. When a couple of things do, this is number 5, right? Is it? Yes. A couple of things. Whenever you're doing a complex question like this, it's really important that you think about it like writing a story. And you want to get all of the parts of the story very clear to understand, right? So the first thing I will do in all of these cases is convert to improper fractions, right? So 8 times 3 is 24 and 1. So this is 25 over 3. Then I have plus 6 2s are 12, 13, 14, 15, 16, 17 over 6. And then I have minus 9 3s are 27, is it? 3 times 9 is 27, 28, 29, 30, 31. So I have 31 over 9. Now I noticed something. I noticed that I could multiply this 3 here by 3, right? Oh, by the way, so you can see how I'm telling the story, right? So the first step of the story is changing everything to improper fractions, right? Now we're gonna change to equivalent fractions. So I noticed that I could multiply this by 3 and I'll get 9, right? I could also multiply it by 2 to get 6. So I could go either way, yeah. Let me see, which way to go? Which way do you think? Do you think we should go by 2 or by... Yeah, don't think you made a mistake just yet, Adi, because, maybe you use a different method. All right, that's fine, right? So you can see here, let me go with 3. 3 times 3 is 9. You know what? No, I'll go with this. I'll go with the 3 times 2. 3 times 2 is 6, and then I have 25 times 2 is 50. So this will be 50 over 6 plus 17 over 6 minus 31 over 9. So you can see by using equivalent fractions, I could add 50 and 17 to give me 50 and 1 is 60 and 7, so that's 67 over 6. Let me know if I'm wrong about that. Minus 31 over 9. And so we kind of boil it down like Baji. Now, we could still do equivalent fractions, but let me just use the normal method, minus 31 over 9. So let me just use the normal method here. First, we'll multiply the denominator. So 6 times 9 is 54. And then we will cross multiply, and we'll get some pretty huge answers here, because 67 times 9 is going to be really big. That is 603. Minus 31 times 6 is 186. And so what you'll end up get is 603 minus 186 is 417 over 54. And of course I will use my calculator to reduce that. I ain't doing that in my head, no, not this hour of the night. And you should get 7 and 13 over 18 for that one. Let me see if anybody get them answers. That's fine. That is fine. Ayanta, you have a question?
Yeah. Why did you multiply 25 over 3 by 2?
Oh, because what I was seeing here, because I was trying to decide, well, what to do. I decided I wanted to add this and this. And so what I did was I turned this into an equivalent fraction where the denominator would have been the same as this, and yeah. So I saw that I could change this 3 to a 6. 3 2s are 6. And so when you're doing equivalent fractions, you had to multiply the numerator by the same thing. So 25 times 2 is 50. So it's 50 on 6 is the equivalent fraction here, plus 17 on 6. And that allowed me to add these 6's here to get 67 on 6. You understand, Ayanta?
Yes, sir.
All right. Any other questions?
No.
Okay. Anybody else have any other questions? Remember, these are the ones you are supposed to get wrong. So feel free to get them wrong. This is equal to, notice the story that I am telling. The story that I am telling is saying that I'm not touching this yet. I ain't touched that. I ain't touched this. I ain't touched this. I ain't touched that. But I am gonna say 4 2s are 8 and 1 is 9 on 2. So you could tell in the story, the first thing I did was change that to improper. The next step in the story, I am changing this, minus. You know that BODMAS says you have to do this first. This is what you have to do first. You can't go 1 6 minus this. This is BODMAS. You have to do your division first, right? So this will be 3 over 4 multiplied by 2 over 9, because I flipped the divisor. So I'm doing this first, right? So you could see 2 into 2 is 1, 2 into 4 is 2, 3 into 3 is 1, 3 into 9 is 3. So what do we have? 3 and 5 over 9 plus 1 over 6 minus 1 times 1 is 1, and 2 times 3 is 6. And well, oh gosh, 1 over 6 minus 1 over 6 is 0. So what we'll end up with is 3 and 5 over 9 plus 0. So the answer, the final answer is 3 and 5 over 9.